Hello everyone, this is Amritpal Singh. Welcome to the next video. Guys, in this video, I'll be talking about what is deep learning, one of the frequently used keyword these days, one of the trending word. Let's get started. So now, what you're looking at, the photo of a computer from 1980s. And the reason why we are kind of delving into a history a bit is because the neural networks along with the deep learning have been around for quite some time. And they only started picking up now and impacting the world right now, right? So if you look back at 80s, you will see that even though they were invented in 60s and 70s, they really caught on a trend or caught wind in the 80s. So people started talking about them a lot. There was a lot of research in that area, and everybody thought that deep learning or neural networks were this new thing that is going to impact the world, that is going to change everything, that is going to solve all the world's problem. But then it kind of slowly died off over next decade. So what actually happened? Why did the neural networks not survive or not change the world? Was it the reason that they were just not good enough, that they are not that good at predicting things, or not that good at modeling, and basically not just a good invention, or there is another reason? So well, actually there is another reason. The reason is in front of us. It's a fact that technology back then was not up to the right standards to facilitate neural networks. In order for neural networks and deep learning to work properly, you need two things. First, you need data, and you need a lot of data, and you need processing power. You need strong computers to process that data and facilitate the neural networks. So that's the reason why it actually couldn't succeed at that point. Now, so if we go further, what are you looking at? You're looking at the picture here. In this picture, we just now looking at the how the data storage have evolved over the years, and then we'll look at how technology has evolved over these years, right? You can see the first picture. It is 1956. Well, there's a hard drive, and that hard drive is only a 5 MB hard drive. That's 5 megabytes right there on the forklift, the size of a small room. That's a hard drive being transported to another location on a plane, and that is what the storage looked like in the 50s. In 1956, you had to pay, a company had to pay $2,500 of those days dollars to rent that hard drive, to rent it, not buy it, to rent it for a month. In 1980s, situation has been improved a bit, right? So you can see now here you got a 10 MB hard drive for $3,500, right? And still very expensive, and only 10 MBs. So that there's one photo these days. And in the 2017, you can see that we got 256 GB SSD card for $150, right, which can fit on your finger. And in that 2024, we got a 1 TB SSD card for just rupees this USD 40, right? So this is how like things are been changing over the time, right? So if we go further, like here we are drawing a graph. You can see we are plot the hard drive cost per GB. You will see that that looks something like this. So we are quickly approaching zero, right? Right now you can get a storage on Dropbox and Google Drive which doesn't cost you anything, the cloud storage, and that's going to continue. And in fact, over the years this is going to go even further, right? So moving further, if we talk about the next point, in this case you can see there is a right now the scientists are looking into the DNA for storage, and right now it's quite expensive. It costs roughly USD 7,000 to synthesize just 2 MB of data, another 2,000 USD to read it. So now that kind of reminds you of all the whole situation with the hard drive and the plane, right? That is going to be mediated very quickly with this exponential curve. 10 years from now, who knows, right? 20 years from now, everybody going to be using the DNA storage if we go down this direction, right? So here in which we are now talking about the storage limits, right? So in this case, you can see here some stats available. You can see it, explore it further. Yeah, this is the data coming from the nature.com website, and basically you can store all of the world's data in just 1 kg of DNA storage, or you can store 1 billion terabytes of data in 1 gram of DNA storage. So that's something to show that how quickly we are progressing, and that is why deep learning is picking up now, that we are now finally at the stage where we can have enough data to train super cool sophisticated models. Back then in 80s, when it was first initiated, that wasn't the case, right? So now moving further, in this case again we have illustration available. So in this illustration, we have an exponential graph or curve available on the log scale. It's not ideally portrayed here, but in the right you can see a log scale, right? So, and this is how the computer been evolving. So again, you can see, check out, this is a Moore's law. You have probably heard of it, how quickly the processing capacity of computers have been evolving. Right now we are somewhere over here, right? You can see year wise we are somewhere over here, and average computer can buy for 1,000 bucks, things at the speed of the brain of the rat. And in between, by this point, right, you can see it will be surpassing the human speed as well, and by 2045 it will surpass all the humans combined. So basically we are entering the era of the computers that are extremely powerful, that can process things way faster than we can imagine, and that is what is facilitating deep learning. So all of this brings us to the question. So what's the question? The question is this one. So in this case you can see, what is deep learning? So what is this whole neural network situation? What is going on? What are we even talking about here? And you have probably seen this picture before as well, or like this. So let's dive into it. Let's see what is deep learning, right? So in this case, this gentleman over here, its name is Jeffrey Hinton. He's also known as the godfather of the deep learning, right? He did his research on the deep learning in 80s, and he has done lots and lots of work, lots of research papers that is published in deep learning. Right now, I guess he's working at Google. So lots of things we are going to be talking about actually coming from Jeffrey Hinton, and you can see a lot. He's got a lot of good YouTube videos as well, explaining the things very well. I highly recommend you to check them those videos out. And so the idea behind deep learning is to look at human brain. It's going to be quite a lot of neuroscience coming up in this tutorial. So, and we are trying to do it here is to mimic how the human brain operates. We don't know that much. We don't know everything about human brain, but that little amount that we know, we want to mimic and recreate it. And why is that? Because the human brain seems to be one of the most powerful tools on this planet for learning, for adapting skills and applying them. If a computer could copy that, we can just leverage what natural selection has, or it can decide it for us. All those kind of algorithms that it has decided are the best, or we can just leverage that, right? So moving further, so what you're looking at, this is a picture of neurons, right? So let's see how this works. We got some neurons, and these are the neurons which are having smeared into a glass and being looked at under the microscope with some coloring. So this is what you can see what they look like. So they basically, they have a body, they have a branches, they have a tail, so on, right? And you can see they have a nucleus inside in the middle, and that's basically what neuron look like. So in the human brain, there's approximately 100 billion neurons altogether. So these are individual neurons. They are basically actually modern neurons. So basically they are bigger, they're easier to see, but nevertheless there's 100 billion neurons in the human brain, and each neuron is connected to as many as thousands to its neighbor, that we all have studied in our biology class, right? So moving further, in this case, this is you got a picture. This is a picture of actual picture of the human brain, and this is a cerebellum, right? This is cerebellum. You can see the red portion, which is a part of a brain at the back. It's responsible for like motorics, or for keeping your balance and some language capabilities and stuff like that. So this is just to show how vast, how many neurons like are there, like billions and billions and billions of neurons that is connecting your brain. It's not like talking about 500 or 1000 or million. This is billions of neurons in there. And yeah, so that's what we're going to try to recreate. So how do we recreate this in a computer? This is the question. So how we can address that question? So let's see. So we can recreate an artificial structure called as artificial neural net. So where we can have a nodes or neurons, right? So we're gonna have some neurons as an input value. These are the values that know about certain situation. For instance, you're modeling something and you want to predict something, and you're always going to want some have input, something to start your prediction off. So that's called as an input layer. This is an input layer. Now then you have an output available here. You can see it, right? So output, that's value that you want to predict, whether that's surprise, or there's somebody going to leave the bank or stay in the bank. Is it a fraudulent transaction or is it a real transaction, and so on. So that is going to be a output layer, and in between we are going to have a hidden layer. So as you can see in the brain, you can have so many neurons, so information is coming through your ears, eyes, nose. So basically you have your senses. Basically your senses are like receiving all the information, and then it's not going just to right away to the output. right? It's going through all these billions and billions of neurons before it gets to the output. And this is the whole concept behind that's what we are going to model the brain, and so we need these hidden layers that are there just before the output. So the input layer, the neurons are connected to the hidden layer, and hidden layer neurons and hidden layer are connected to the output value. So that's just pretty cool. So what it is all about? What is deep learning here? This is why it is called deep learning, right? There's nothing deep in here. So this is the kind of option which might someone can say it's a shallow learning. So where there is nothing or isn't much deep going on. So why it is called deep learning? Let's check it out. So if we go further, the last slide of this, if we go further, we in this case you can see if we separate it even further, and you can see we have not have just one hidden layer, we have lots and lots of hidden layer in between, and then we connect everything. So just like in human brain, connect everything, interconnect everything, and that's how the input value of process goes through those hidden layers, and just like human brain, and then we have an output value at the last, right? And so now we are talking about deep learning. So that's what deep learning is all about at a very abstract level. So I hope you must have understood from this short little video. So what is deep learning? In my upcoming video, I'll be talking about more on it, some algorithms, right? So thanks for watching, guys. See you next video.